Numbers, always a fascination for mathematicians. The concept of number is as old as human existence itself. Numbers have evolved as humans evolved, from counting sheep to computers. In this evolutionary journey, mathematicians have discovered different types of numbers such as integers, rational numbers, irrational numbers, etc. Expressing numbers in various forms is an important aspect in number theory. We can express a number as a product of two or more numbers, or a sum of two or more numbers, or as an exponents, and many other forms. Each of these forms has its own applicational value. For example, if I express a number as a sum of square of two numbers, we know that these three numbers form the sides of a right angle triangle. In this case, 5, 3 and 4 are the sides of a right angle triangle. This is got by using Pythagoras theorem. So this format helps us to identify Pythagoras theorem and to identify a right angle triangle. So in this way, we have many special ways of expressing any number. But today we are going to specifically see this type of expressing a number as a product of two or more numbers. Today in Ganitika.com, we are going to learn about one such form of expressing a number using a special number called prime numbers. We are also going to see prime factorization, which is writing a number as a product of prime numbers. From here on, we will also find HCF and LCM. HCF is highest common factor, LCM is lowest common multiple. This concept has its application in many areas from computer algorithm to biochemical laboratories, but the most significant application is in mathematics itself. This forms the base for bigger concepts such as algebra, calculus, statistics, probability theory, etc., which you will learn in higher classes. So, welcome to Ganitika.com, a website for mathematics lovers, learners, and leaders, and let's see what are prime numbers first. Consider these four numbers. You can write them as product of two numbers as shown here. 1 times 10 is 10, or 2 times 5 is also 10. So you can express 10 as a product of two numbers in two different forms, 1 times 10 and 2 times 5. So now you try to write 24 as product of two numbers, 49 as product of two numbers, 215 as a product of two numbers. Once you are done, you can continue with this video. So, 24 can be written as 1 times 24. It can also be written as 2 times 12. If you go for 3, 3 times 8. If you go for 4, 4 times 6. And 5 is not possible because 24 is not divisible by 5. So, you can write 24 as 4 different products. 1 times 24, 2 times 12, 3 times 8 and 4 times 6. So have you done this for 49? Of course, the first product would be 1 times the number itself. This is common for all the numbers. 1 and the number itself are the first set of numbers that can be written as product of two numbers. Next is 7 times 7. You cannot have any other products for 49. So there are only two options, 1 times 49 and 7 times 7. Whereas for 215, the first product obviously would be 1 times 215. And the second product would be 5 times 43, and there are no other products for 215. So you can see that different numbers can be expressed as a product of two numbers in different forms. For example, 10 has only two forms, 24 has 4 forms, 49 has 2, but 215 also has only 2. You can try this out with more numbers in your leisure time. Consider these 4 numbers. Try to express them as a product of two numbers as you seen just now. Pause the video here. Try to express these numbers as a product of two numbers. If you're ready, I'm going to show you the products now. The first obvious product is 1 times 11 for 11. For 17 as well, 1 times 17. 23, the first obvious product is 1 times 23. 1 times 97 for 97. So obviously, the products 1 times the number itself is the first product that you might write for any number, and it is common for every number in the world. Can you write this in any other set of two numbers? Can we write 11 as product of any other two numbers? No, it's not possible. It's not possible for 17, 23 as well, and 97 as well. There is no other options of writing these 4 numbers as a product of two numbers other than 1 and the number itself. Considering these 4 numbers that we did first, we can see that we had more than one option in writing them as product of two numbers. other than 1 times the number itself, we had at least one other option, which means these numbers are called composite numbers. So composite numbers are those which can be written as product of two numbers other than 1 and the number itself. Considering these four numbers, we can see that there were no other options other than writing them as a product of two numbers using 1 and the number itself, and therefore these numbers are called prime numbers. So in this video, we are going to see what are prime numbers and how to express a number as a product of prime numbers. What are prime numbers? Numbers that are divisible only by 1 and the numbers themselves. So you can express a prime number as a product of 1 and itself, which means, in other words, they are divisible only by 1 and the number itself. So these type of numbers are called prime numbers. There are some interesting properties of prime numbers. 1 is neither a prime number nor a composite number. So if by definition 1 is divisible by 1 and 1 is divisible by itself, but 1 is not taken as a prime number nor a composite number. It's a neutral number. And the next interesting property is 2 is the smallest prime number. The first prime number in the set of positive numbers is 2, which is the smallest prime number. Also, 2 is the only even prime number. Isn't it interesting? Any other even number will be divisible by 2. Therefore, no other even number can be a prime number. Therefore, 2 is the only even prime number. Even number as well as a prime number, which is 2, which is also the smallest prime number. So 2 has a lot of speciality when it comes to prime numbers. Now let's see what are prime factors. If I can express a number as product of two numbers, say 24 can be expressed as 6 times 4. I can also express this as 8 times 3 or 2 times 12 as you wish, but I'm just choosing 6 and 4 in this case. So I'm writing 24 as 6 times 4, but I can still split the 6 as 3 times 2 and the 4 as 2 times 2. So if I split 6 and 4 again and write it as product of numbers, I will write this as 3 times 2 times 2 times 2. So you can see that all these numbers are prime numbers. 3 and 2 are prime numbers. So when I write 24 as 6 times 4, I am expressing 24 as a product of composite numbers. And when I write 24 as 3 times 2 times 2 times 2, I am expressing 24 as a product of prime numbers. So this is called prime factorization, which in other words is writing a number as a product of prime numbers. So if you can write 148 as a product of prime numbers, you are prime factorizing 148. So let's try to factorize this into prime numbers. Since it's 8, you know that this is an even number, therefore this is divisible by 2. So let's start dividing 148 by 2, which is 74. So 74 times 2 is 148. Still 74 is an even number, so I can divide 74 by 2, which gives me 37. Now, can you divide 37 by any other number other than 37 and 1? No. Therefore, this is a prime number, and therefore you stop the division here and write 148 as 2 times 2 times 37. Take up all the divisors there and write them as 2 times 2 times 37, which will give you 148. So we have expressed 148 as a product of prime numbers. Now try to prime factorize 315, which means you have to write this as a product of prime numbers. So start on with the same process. 315 divisible by 5. So I can write this as 5 times 63 as 315. Now 63 is not a prime number. It's still divisible by 7. 7 times 9 is 63. 9 is not a prime number. 9 is still divisible by 3. 3 times 3 is 9. Therefore, now we end up with a prime number 3 at the end. Therefore, we stop the division. Now the prime factors are 5 times 7 times 3 times 3. So this is how we have written 315 as a product of prime numbers. So this is how we wrote 315 as product of 5 prime numbers. We started with 5, divided 315 by 5. We got 63, and then we divided 63 by 7. But when we come to this stage, instead of dividing by 7, if I divided this by 9, I would have got a 7 here, and the product would be 5 times 9 times 7, and you can see that 9 is a composite number. So we have not expressed 315 as a product of prime numbers here, but we have got a composite number in the product, so this is not prime factorization. We could have also done this in another way. 315, 63. And instead of using 7 or 9, we could have used 3 here. We could have got a 21 and we could have divided that by another 3, which will give you 7, and we stop the division here because 7 is a prime number. Instead of 3 and 7, I could have swapped 7 and 3 as well. We would have divided 21 by 7 to give a 3. So that is okay. But what you need to notice here is 315 now can be written as a product of all prime numbers here, in this case as well. So the catch here is when you are using the numbers in this place, you always use prime numbers. You never use composite number, because if you use composite number, your product will give you a composite number in between. Therefore, you better use always prime number when you are dividing a number and when you want to prime factorize a number. So use prime numbers as divisors in this case. You can also use tree diagram like this, 315 as a product, 5 and 63. Now 5 is a prime number, so circle it off. 63 can still be divided as 2 numbers, 9 and 7. Now 7 is a prime number, circle it off. 9 is not a prime number, it's still a composite number. So write this as 3 times 3. Until you get all prime numbers, you keep going on with this tree diagram. Take away all the circled prime numbers, and the product of those circled numbers will give you the prime factors of 315, 5 times 3 times 3 times 7. So this is another way of splitting the number as prime factors. Now let's go on to the important part of this video, HCF, which is also called GCD. HCF is highest common factor, GCD is greatest common divisor. So both are the same. In some educational system we use GCD, in some other systems we use HCF. So according to your system, you can consider which one you are using here. I'll be discussing both of them in this video. GCD or HCF, both are common factors or common divisor, which means we are going to find the common factor between two numbers and we are going to find the highest or the greatest among these two. So before we proceed, let's find out what is a divisor. What do you mean by a divisor? Let's say 24 can be written as 6 times 4, or it can also be written as 3 times 2 times 2 times 2. So we can see that 6 times 4 means if you divide 24 by 6, you get 4. So 24 is divisible by 6. 24 is divisible by 4 as well, because when you divide 24 by 4, you will get 6. In the same way, all these numbers can divide 24, therefore they are called divisors. So the numbers that can divide the number is called divisors. So 24 is divisible by 6, 4, 3 and 2. Therefore 6, 4, 3 and 2 are called the divisors of 24. So you can write it in order as 2, 3, 4 and 6. But are they all for 24? Let's collect all the list of divisors here. So we just saw that 2 is a divisor of 24, 3 is a divisor of 24, 4 and 6 are also divisors of 24. This is what we just saw, but the list is not completed yet, because I can write 24 as 1 times 24 as well, which means 1 is a divisor and 24 is also a divisor. Therefore I can add it to the list, 1 and 24 as the divisor for 24. I can also write 24 as 2 times 12. Therefore, I can write 2 as a divisor, which is already there, but left over is 12. So 12 is also another divisor in the list now. The next way of writing 24 is 3 times 8. 3 is already there in the list, so I'll add 8 to the list now. Therefore, the divisor now is 2, 3, 4, 6, 1, 24, 12 and 8 so far. Now 24 can also be written as 4 times 6. Both the numbers are already there in the list, so I need not add them into the list now. So for 24, these are the different options of writing them as product of two numbers, and therefore these are the set of divisors for 24. So 24's divisors are 1, 2, 3, 4, 6, 8 and 24 and 12. So how to find all the divisors? How is it too difficult? How can we find them all? So let's start collecting the list of divisors for, say for example, 105. The first option would be 1 times 105. So for every number, 1 and itself will be the first set of divisors. The next is try to divide 105 by 2 and see what number you get here. It's not divisible by 2, so this product is not possible. 105 then divided by 3 and see what the number you get. You get 3 times 35 is 105. So 105 divided by 3 gives you 35. 105 divided by 35 will give you 3. Therefore 3 and 35 are also divisors. Now let's proceed to 4 times what gives you 105. 4 is not a divisor of 105. So therefore you leave this step and go to the next step. Divide it by 5 and see what number you get. You will get 5 times 21. Therefore 5 and 21 are also divisors of 105. Proceeding like this, you can see whether it is divisible by 6. It is not divisible by 6, obviously. Next, go to 7. We can see that 7 times 15 is 105. Therefore, 7 and 15 are also divisors of 105. We can keep proceeding like this to find many other divisors in the list. Let's see how the prime numbers will be helpful to find these things. So write 105 as 3 times 35. Prime factorize this. 35 can be written as 7 times 5. Therefore, 3 times 7 times 5 is the prime factorization of 105. Now let's write the list of numbers that we have already got here. 105 are the first set of prime factors, divisors. 3 and 5 and 7 are already there on the prime factorization, and 35 is also one of the divisors of 105. So 3, 5, 7, 35 are the divisors that we have seen so far. But we can also collect more divisors from what we have here. From the prime factor form, 3 times 7 times 5, we can see that 3 times 7 will give you 21. If I collect 3 and 7 together and write it as 21, I can write 105 as 21 times 5, which means 21 is also a divisor now. If I divide 105 by 21, I'll get 5. Now combine 3 and 5, which will gives you 15. So 15 times 7 will give you 105. Therefore, we have already got the 7 in the list, which is left over is 15. So I'll put 15 here. Now I don't have any other combinations of 3, 7 and 5 here, because 7 and 3 is 21, 7 and 5 is 35, which is already there. 7 and 5 and 3 and 5 and 7 and 3, we have collected all of them. Therefore, this is the final list for the divisors of 105. So this is one way of finding all the divisors for any number. So let's find the common divisors of 24 and 105. 24, the divisors are here, 1, 2, 3, 4, 6, 8, 12 and 24. We just saw 105, 1, 3, 5, 7, 15, 21, 35 and 105. Now try to collect the common divisors from this list. The first common divisor we can collect is 1, then it is 3. So there are only 2 common divisors here, 1 and 3. Among these common divisors, the greatest divisor is 3. Therefore, the greatest common divisor of 24 and 105 is 3. But this is very tedious to find all the divisors. Therefore, we can use prime factorization method. So let's prime factorize 24 and 105 as we did before. 3 times 2 times 2 times 2 is 24. 3 times 5 times 7 is 105. Now collect the common factors, which is 3. In this case, there are no other common factors. So the highest common factor here is 3. So HCF of 24 and 105, which is the same as GCD of 24 and 105, is equal to 3. So this is how we use prime factor to find the HCF of any 2 numbers. Let me give you one more example, 168 and 54. If you have understood how to find GCD as well as HCF, pause the video here and find GCD or HCF using both the methods, divisor method and factors method. So let me first do it with divisor method now. Are you ready? So the divisors of 168 is so much, 1, 2, 3, 4, 6, 7, 8. If you have done this, you could see that it goes on for a long list. But 54 is not that long, 1, 2, 3, 6, 9, 18, 27, 54. I stopped for 168 up to 42 and put 3 dots over there because I don't need any more numbers, because I'm going to compare that with 54. So I don't need to go beyond 54 there. I'm not writing those divisors there. So among these divisors, pick up all the common divisors, 1, 2, 3 and 6. Among these common divisors, pick up the greatest common divisor, which is 6 here. Therefore, using common divisor method, the greatest common divisor of 168 and 54 is equal to 6. Now let's try to do this with factorization method, prime factor method. Prime factoring 168, 7 times 2 times 2 times 3 times 2. You could have written this in any other way. You could have started with 2 times 2 times 2 times 3 times 7. But as long as you have all these 5 numbers as prime factors, that's fine. 54 can be written as 2 times 3 times 3 times 3. So this is the prime factorization of 54. So now collect all the common factors. 2 and 3 are the common factors of 168 and 54. Now what you do for HCF is you want the highest common factor. 2 is one common factor, 3 is another common factor. If I multiply 2 and 3, I'll get the highest common factor, which is 6. So in this way, we can find highest common factor of 168 and 54. Try to find HCF or GCD for any other two numbers as you wish. Now try to find the GCD or HCF of 42 and 25. Are you ready? Divisors of 42 are 1, 2, 3, 6, 7, 18, 21 and 42, whereas divisors of 25 are only 1 and 5. Now find the common divisors, 1. Therefore the greatest common divisor is just 1 here. It is easy to find this using divisors method than factorizing method. Let me see how to do it with factors method. 42 factorization, 2 times 3 times 7. 25 is 5 times 5. Now if you look for the common factors, we don't find any common factors here. But what we are missing here is we have a multiply by 1 hidden in this factorization. So there is a multiplication by 1 in both the cases. Therefore 1 becomes the common factor. Therefore the HCF of 42 and 25 is 1. When you prime factorize any two numbers and if you don't see any common factors, then the highest common factor is 1. So this is what you need to take away from this particular point. HCF of any two numbers which doesn't have any other common factors will be equal to 1. And these two numbers are called co-prime numbers. Next, let's proceed to multiples of a number. If I want to find the multiples of a number n, then I'll write this as n times 1, n times 2, n times 3, n times 4, n multiplied by 1, n multiplied by 2, n multiplied by 3 and so on as much as I want. For example, if I want to write multiples of 3, this will be 3 times 1 which is 3, 3 times 2 which is 6, 3 times 3 which is 9 and 3 times 4 12, 3 times 5 will be 15 and so on. These are the multiples of 3. Now try to write the first 5 multiples of 7. Write it in your notebook. So it starts from 7 times 1, 7 times 2, 7 times 3, 7 times 4, etc. up to 7 times 5. So the first 5 multiples will be 7, 14, 21, 28 and 35. You don't put the 3 dots there because I just asked you to write the first 5 multiples only. So stop at 35. Let's see what is LCM. LCM means least common multiple. That's why I told you what a multiple is. So when you are finding the multiples of two numbers, you are going to find the least common of both the multiples. This is what the basic idea about LCM here is. So let's find the LCM of 4 and 6. So for that we need to find the multiples of 4 and multiples of 6. Are you ready to write the multiples of 4 and 6 in your notebook? If you are ready, we can check the multiples of 4. How long you should write? You can just write 5 or 6 of the multiples. And for multiples of 6, again write some few of them, 5 or 6. If you could find out at least 2 multiples common, you can stop there. In this case, we can pick up the common multiples from both the lines. So the first multiple that you are able to see is 12. 12 is common to both and 24 is the next multiple, and if you kept writing on, you would find more multiples common to both of them, but we are only interested in finding the lowest common multiple. Therefore we just wanted at least 2 so that we can find the lowest of everything. Therefore here the least common multiple of 4 and 6 is 12. So if you write the multiples of both the numbers and if I pick up the common multiple, among the common multiples, pick up the lowest of all, then you are going to find the LCM of those two numbers. Try to find the LCM of 10 and 12. Write the multiples of 10, write the multiples of 12, pick up the smallest multiple of all of them. Multiples of 10, 10, 20, 30, 40, 50 and so on. Multiples of 12, 12, 24, 36, 48, 60 and so on. So far we couldn't find any common number. But if I wrote 60 here, I can see that 60 would be the first common number. So I don't need to go further. 60 is the first common multiple. Therefore least common multiple should be 60 of 10 and 12. So this is one way of doing this. There is another method of finding the LCM. Instead of listing all the multiples, as long as you want to, it's easier to find the common number that divides 10 and 12, which is 2 here. So 2 divides both 10 and 12. So I'll use 2 and divide 10 and 12 here. So dividing 10 by 2, I'll get 5. Dividing 12 by 2, I'll get 6. And for both these numbers, we don't have any common numbers. Therefore, we stop it here and we collect all the numbers that we just had, 2, 5 and 6, multiply them all. And then the product of these numbers will give you the least common multiple. So we just start with both the numbers, find the common divisor for both the numbers, keep dividing that until you have two numbers where there is no common divisor for both of them, and collect all the numbers from divisors to the end, multiply them all. That will give you the least common multiple. So we'll do one more question. Least common multiple of 28 and 32. Try to do this in the division method. 28 and 32. 28, 32. Common number that you can immediately find out is 2 because it's both are even numbers. So dividing 28 by 2, 14. 32 by 2 is 16. Now we still have common divisors for both of them, which is 2. So I can choose 2 here. 14 divided by 2 is 7, 16 divided by 2 is 8, and now 7 and 8 are the numbers that we are left over with, and there is no common number between 7 and 8. Therefore, we stop the division here. We collect all the numbers, 2 times 2 times 7 times 8, and that will be the number for LCM of 28 and 32. So instead of starting with 2, if you had identified that 4 is a common divisor for 28 and 32, we would have got 7 and 8 in the beginning itself. So we can write the product as 4 times 7 times 8, which also gives you the same number as 224 for 28 and 32 LCM. In this case, what you can notice here is when you find the divisors for the two numbers, you don't have to find a prime number. It can be a composite number as well. So we are not going to prime factorize it. We are just going to find the common divisor of the two numbers, and we are just going to start dividing those two numbers by that common divisor. It can be a composite number, need not be a prime number. If it is a composite number, it becomes easier because the number of steps would be less. What have we learned today? Composite numbers, the numbers which can be written as product of two numbers other than 1 times itself, which is divisible by more numbers than 1 and itself. We can put it in that way. Prime numbers which can be divided only by 1 and itself. Prime factors, you can write a number as a product of prime factors, which is called prime factorization. Multiples, when you find the multiples of a number times 1, the number times 2, times 3, times 4 and all, it is called multiples. You can find the highest common factor or greatest common divisor of two numbers, and you found least common multiple of two numbers. So this is what we have learned in this video. I hope you enjoyed this video. Thanks for watching. Subscribe to this YouTube channel, like and share my videos with your friends and families. Thank you very much.